Today, we are going to look at graphing and how to create an effective scientific graph. You'll want to have handy for this lesson a ruler, some graph paper, and a pencil. So before we look at the steps to actually creating an effective graph, let's talk about what a graph is and why it is so important to us in science. So graphs are diagrams which give us a visual representation of the relationship between variables. This allows us to very quickly and visually see, observe, and understand the relationship between those variables without having to look through, analyze, and interpret large sets of data. For this reason, graphs are especially helpful in communicating scientific information, which is what you'll be using them for in class. So now we're going to walk through the steps to creating an effective graph, and we will walk through an example of creating a graph together. So your first step, before you even pick up pen and pencil to start creating your graph, is to identify your variables. So the first thing that you want to do is find out for the particular graph that you are creating, what are the independent and dependent variables. If you need a reminder on how to do that, please make sure that you go back and watch our video on independent versus dependent variables. So we look at this example here. It says that during her trip to the lake, Zaria observed that as the water of the lake got deeper, its temperature decreased. So if I was hoping to create a graph of this, the first thing I would do is think and analyze this situation and determine which variable is my independent and which is my dependent. Based on this example, I can see that water depth is my independent variable, and the water temperature is the dependent variable. Your next step is to create a title for your graph. Now you will see that in order to create an effective title, you will need to know the independent and dependent variables, which we found in step 1. So the title of your graph should always be in this format: the effect of the independent variable on the dependent variable. So in order to create your title, all you will do is simply plug in the independent and dependent variable for your situation, which you identified in step 1, to create the title. So for our example, our title should look like this: the effect of water depth on water temperature. Your next step for creating your own graph is to set up and label your axes. So here's where you're going to need your ruler and your graph paper. So how we want to set up an axis is by using the ruler and the grid lines on the graph paper to draw our X and Y axis. Now, this is a review from math class, but keep in mind that your horizontal axis down here is your X axis, and the vertical axis here is your Y axis. The next step that you want to take is to label each axis. Now, we don't want to just label them X and Y axis. We want to label them with the variables that we will eventually be plotting there. So the rule for setting up your graph is that your X axis represents your independent variable. So you will then label your X axis with whatever your independent variable is. You will then label your Y axis with whatever variable is your dependent variable.
Okay, so now let's see what that would look like on our graph paper. So now, depending on where you're working on your paper and how much space you have, will determine how big your graph should be. But in general, we want to make our graph as large as we possibly can so that it is more clear to read. So since I have the whole paper, I'm going to just set up my graph right here in the middle. So you're going to use your straight edge and the grid lines that already are on your graph paper to find a place for your Y axis. You will then simply draw a straight line to represent the Y axis. You will then create a line that intersects exactly at the end of your Y axis and comes out towards the right. This is going to represent your X axis. Now we have our axes set up. My Y axis here and my X axis here horizontally. Now you don't need to do this, but I am going to label them simply for the sake of the lesson. So always remember that your Y axis is the vertical axis and your X axis is the horizontal. Now your next step is to go ahead and label your axes. So if we think back to our example from this lesson, we are looking at the effect of water depth on temperature. So we know that our independent variable belongs on our x-axis. We've identified that water depth is our independent variable in this example. So I'm going to go in and label water depth on my x-axis. We also have determined that my dependent variable is water temperature. So just the same, I'm going to come to my y-axis and I am going to label water temperature, which is my dependent variable. One small thing to note is that you want to make sure that you place your labels far enough away from the actual axis that you will have space to label your interval.
Now, once we have our axes set up and labeled, we're ready to move on to the next step. The next step is to determine and label the intervals of our graph. Now here is where the most technical mathematical piece of the graphing is going to come in. So you want to make sure that you take your time and determine your intervals accurately. So when we say an interval, we simply mean the numerical or the amount of numbers in between each value on your graph. So if we look here, we can see that it goes 0, 3, 6, 9, 12, 15. We can see that the interval on the x-axis here is 3. So again, it's just the amount of numbers in between each value. Now, in order for your graph to be mathematically accurate, the amount of numbers in between each value needs to be exactly the same. And in order for all of your values to fit on your graph, it needs to be a specific number. In order to determine which number works best for the set of data that you have, we will want to use the formulas here. So to determine the interval for each of your axes, you are going to use these formulas. For your y-axis, you're going to find your highest y value from your data set and divide it by the number of squares available in your graph. For the x-axis, it is the exact same formula, except here you're going to choose your highest x value instead and divide it by the number of squares available on that axis. Once you do the division, you are going to, if you get a strange number like a decimal or a strange odd number, you're going to want to round up. So we always round up to the nearest magical number. These are nice, clean, even nice numbers that work well as intervals on graphs. So those numbers are 1, 2, 5, 10, 20, 50, and 100. So for example, if we do our calculation and we end up with a number like 0.87, you are not going to use 0.87 as the interval on your graph. Instead, you are going to round up to the closest magical number, which in that case is 1. A couple of things to take note of here when creating your graph is that this point at which the y and x axis intersect is called our origin. In almost all cases, our origin should be equal to 0. Now, there are some strange cases, such as with time and years, where we may need to start at a different number. But for our purposes now, our origin should always be equal to 0. If you remember, I said that the spaces between all values must be equal. So that means if we determine that our interval is 3, even from 0 to the first value must be equal to 3. One mistake that we see often is that people will start 1 here and then will begin their interval. Please make sure that even from 0 to your first value also accurately represents your interval. Now let's look at an example of calculating our intervals for our data set.
So now let's look at our example and find out how to find the most appropriate intervals for both our x and y axis. So here we have our data set. And here we have our graph. So if we remember, in order to find the x interval, we want to find the greatest x value or the greatest value of our independent variable and divide it by the number of squares available on that axis. So first, let's look at our data points and find our greatest x value. So if we look at my independent variable, which we know is water depth, we see that the greatest value here is 200. So I'm going to place 200 in the numerator. Now, I've already taken the time to go back and look at my graph and count the number of squares available on that x-axis. In this case, it is 22 squares. For the sake of the video, we won't go through and count, but I simply went through and 1, 2, 3, 4, counted the amount of squares available on that axis and got 22. So now we're going to place 22 in the denominator. We will then simply take our calculator and divide 200 by 22. to get 9.09. Now, remember, we do not want to use a number like 9.09 for our interval. We want to think back to our magic numbers and always round up to the closest magical number. In this case, we are very, very close to 10. So the interval that we are going to use on that axis is 10. We're then going to repeat the exact same process for the y-axis. So our 0.
For the sake of the video, I've fast forwarded here, but you can see that I followed the same process to calculate the interval for our y-axis.
Which in this case is 1. So the interval we will use on that axis is 1. Now our job is to actually go in and label our axes or separate them using the appropriate intervals. So if we got x interval of 10, so what we're going to do is we're going to, using that interval, go ahead and mark or annotate every single square and the value that it represents using that interval. So I'm actually going to skip a space just so that it's a little bit cleaner here. You, however, can label every single interval if you prefer. So 10, 20, we just are going to count by that interval. 40, 50,
60, 70, 80, 90, 100. And you will just continue in that same process, making sure that you are counting by the same interval and skipping the same amount of space between each value. 30, 140, 150, 160. You can see that it starts to get a little bit messier. That's why I like to skip a space. You also can write vertically instead if that helps you to fit your values. 190, 200.
10, and 220 just for good measure. And there we can see that all of our intervals are separated by a value of 10. And we can see that we have space to fit all of our values all the way up to 200. We're then going to repeat the process for the y-axis using the interval 1.
So as you can see here, I'm just repeating the process using the interval 1 on my y-axis.
16, 17, 18, 19. And there we have our y-axis labeled using the correct interval of 1.
Now that our intervals are correctly calculated and labeled on our graph, we're ready to move on to our next step. Now our next step is to simply plot the points. Now, remember that we have coordinates in an x, y format, x values being our independent variable, and y values being our dependent. We simply look at the coordinate, 50, 18, 75, 16, so on and so forth, and plot them on our graph.
So now that we're ready to plot, we need to come back to our data in order to find our data points. So starting at the top, our x and y data points are here. Let's go ahead and plot those coordinates. So our first coordinates are 50, 18. So we will go to 50 on the x-axis up to 18 on the y-axis. So that will look like this, 50, 18. Our next data point, 75, 16. Now, in a case like this, where our intervals are 10, we do not have an exact point for 75. This is where you will need to eyeball and find out approximately where 75 would lie. Now, if I know that it's divided by 10, 75 is half of 10, I know that it should be somewhere right in the middle of my 70 and my 80 data point. So right in the middle here is where that point should go. And again, that y value was 16. So I'm going to come all the way up here to 16 and plot my point right there. You will then continue this process for the rest of these data
points. Now that our
points.
Points have all been plotted on our graph, we're ready to move on to the very last step of the graph, which is adding our line of best fit. So the line of best fit, as you see in the picture, is a trend line or a line through our data, which best shows the relationship between the variables. So as you can see there, it doesn't hit every data point, and in some cases it may not actually hit through any data point, but it gives us an average or a best picture of what that data is doing. In order to draw our line of best fit, we want to grab a ruler and draw a straight line straight through the data points. And the rule to follow is that you want to have approximately the same amount of points above that line as below the line. So if you look here, you just sort of want to eyeball it. You can count if you want to, but in order to know that it's an approximately good line of best fit, you should have about the same amount of data points up here above the line as below the line. So now let's look at what that would look like for our example.
So as you can see here, we have a set of data that's close, but doesn't follow a completely linear path. So in order to find that line of best fit, we want to take our ruler, go through the data points, but again, we want to make sure that we have, again, approximately the same amount of points above and below the line. So in this case, if I were to draw it here, I would have about 2 or 3 above and about 2 below. It's about as close as we're going to get for this one because there are an uneven amount of data points. But you can see it passes through all of my data, and I have approximately the same amount on top as I do on the bottom of the line. And then I am simply going to draw that trend line straight down. And it should look something like